I need to draw the most stable chair of these two compounds. Notice that this one right here, both my substituents are pointing to the back, but they're pointing to the same side. So this is the cis. This one, I have one substituent in the back and one in the front. So this one is a trans. Cis and trans, these two compounds that I have here, are stereoisomers of each other. And I'm going to go ahead and I'm going to draw a chair. Drawing chairs require practice, so I need you to start practicing. I want to go to the most stable chair automatically. So what I'm going to do is that I'm going to try to compare the size of my two substituents, because I know that the more substituents I have equatorial, the better. But since they're both different, the bigger substituent would be much better on an equatorial position. So between fluorine and methyl, the methyl occupies more space, is a bigger group. So I am going to put the methyl on the equatorial position on both my chairs. So I'm going to go to carbons 1 and 2. And I'm going to mark my positions in pencil. Remember, this is my favorite carbon, and I know that on that carbon the axial goes straight up, the equatorial goes straight down. So then I alternate up and down, going around the chair. All right, so we said that the methyl was bigger than the fluorine atom. So I'm going to put my methyl on the equatorial position. I'm going to do that for both. All right, so I have my methyl on my equatorial position, and now I have to put the fluorine atom on carbon number 2, but I have to be very careful that I put them cis or trans depending on which isomer I'm talking about. Let's go to the cis right here. My methyl is pointing down. For that fluorine to be cis, it needs to also be pointing down, and the down position on this carbon is going to be axial. If I was to flip this chair, the fluorine would go equatorial, the methyl would go axial, and an axial methyl is less stable. So automatically this right here is the most stable chair conformation for this compound, for the cis isomer. Now in the trans, things are looking a little better because the methyl is equatorial down, what I need to think is down, and I need to put the fluorine trans to the methyl. So if the methyl is down, that fluorine needs to be going up. So I come to this carbon right here and I pick the up position, and as you can see, we got lucky. We got a second equatorial position. So this one right here is the most stable chair for the trans. If you had to flip this chair, to interconvert that chair, you would go to both substituents on axial positions, and that would not be good. So this one is the most stable for the trans. This one is the most stable for the cis because the biggest group is on the equatorial position.